we are going to start with calculations involving reacting volumes of solutions. And we need to know, one, the concentration. One thing we need to know is the concentration of this solution. How are the particles distributed there? Number two, what is the volume of this solution? Information about this solution. We are going to exactly be able to calculate how many moles, how many particles of sodium hydroxide are inside there. And how do we do it? Getting moles in a solution. The way we do it, calculating moles in a solution, the way we do it is this. I have said, one, we have the volume of the solution. And number two, we have the volume of the solution, and number two, we have the concentration of the solution. But what is the concentration of the solution? We quote concentration of the solution in terms of moles per liter. How many particles are there of the solute in 1 liter of that solution? So concentration is expressed. It is expressed in terms of concentration is expressed in terms of moles which are there per liter of the solution. Because you know the quantity of solution can be so much, can be so little, and so on. But universally, we look at 1 liter. How many particles are there? How many moles of the particles are there? Then, if we give that quotation, we have already given the concentration. Another way we give the concentration of a solution definitely is quoting the mass of the solute in 1 liter of that solution. Other way we can give it is like, for example, kilograms per liter. How many kilograms of the solute are found in a liter of that solution? But as you have told you, here we are dealing with calculating the products, calculating the amount of the products formed in a chemical reaction, and this reaction is involving particles. So in this case, therefore, we are supposed to mainly confine ourselves to expressing or even reading the concentration of solutions using moles per liter, the number of particles which are there in a liter of the solution. So let us I want to give you examples of quoted solutions, concentrations of solutions. For example, somebody talking about 0.5 m sodium hydroxide. Somebody talking about 0.3 m sulfuric acid. These are examples of quotations of concentrations of these two substances. 0.5 m sodium hydroxide means what? Or we read it how? We read it as 0.5 molar sodium hydroxide, not 0.5 moles. It is 0.5 molar sodium hydroxide, 0.3 molar sulfuric acid. So don't confuse this m with moles. This is simply a quotation of the concentration. And for example, 0.5 m sodium hydroxide, it means that in 1000 centimeters cubed, which we are saying, here is a liter, it has got 0.5 moles of 0.5 moles of sodium hydroxide. So that is how we express concentrations. But the question is, at this time, I will not train you, or I will not talk about how we make molar solutions. Maybe that could be maybe for another day. And since people, because we are doing revision, let me not go let me not go into that area. The first thing I will talk about is how we dilute solutions, diluting Molar solutions, diluting solutions. I want us to dilute two solutions here, theoretically, although still we can do it practically, and we see how we dilute solutions. Let us look at this. Here I have got a question, and the question is reading: find the volume of 2m sodium hydroxide solution required to be diluted to 250 centimeters cubed to make A 1.5 m solution, B 0.8 m solution. So here we are having a solution which is which is very concentrated. It is 2m, and that's what we do in the laboratories. We keep solutions when they are a bit concentrated, and many times, because we use very dilute solutions, we dilute those concentrated solutions to make them to the level that we want. Like here we have 2m sodium hydroxide, and we want to make out of it 1.5 m solution. And how do we go about that? The molarity before dilution, let me call it M1, and let me call the volume before dilution as V1, and let me call the molarity or the concentration of this solution before diluting as M2, and after dilution as V2. That is the volume after dilution. The way these two relates is simple. That if you take the molarity before dilution, you multiply by the volume before dilution, before you have added water, the product will be equal to the molarity after dilution multiplied by the volume you get after you have added water or after you have diluted. So we are going to do that in these two questions, and then we find or rather we dilute the solution. So this sodium hydroxide before dilution, that is its molarity, that is M1, is 2m. And the volume is the one that we are asked, that is V1. Before dilution, what is the volume that we must dilute to make the concentration to shift from 2m to 1.5 m? That is the question. Then the volume after dilution, we are told that we want to make 250 centimeters cubed, and the molarity we want to make, that is the molarity we shall have after dilution, is 1.5 m. So how can we go about this? It is simple. M1, that is 2, multiplied by V1, that is volume before diluting, is equal to 1.5 m, that is molarity after dilution, multiplied by the volume after dilution, that is 250. And in this case, the V1 becomes 1.5 moles. You can write as moles, multiplied by 250 centimeters cubed over 2. And when you work it out, so the volume that we are supposed to dilute to changes to 250 centimeters cubed as the concentration also drops. That is, the V1 should be equal to 187.5 centimeters cubed. And that is how we dilute solutions. Let us now, that is part A. That is part A. Let's go to part B. We want to dilute the same solution to put it to 0.8 m solution, that is the concentration. And we know this, that 1 is equal to 2m. And the concentration, or rather, sorry, and the volume before dilution is the one that we are looking for, because that's the volume we are adding water to change it from whatever it is to 250 centimeters cubed. And the molarity after dilution, the molarity we want is 0.8 m, and the volume after dilution is 250 centimeters cubed. How do we calculate this? We know M1, V1 is equal to M2, V2. So 2 multiplied by V1, that is what we are looking for, should give us M2, V2. Therefore, V1 is equal to, all of that, this is 0.8 multiplied by 250. So V1 is equal to 0.8 multiplied by 250 divided by 2. And this one becomes 100 centimeters cubed. So what therefore we are required to do is very simple to make that diluter solution. We are required to draw a solution, and a solution which is 100 centimeters cubed. And this solution, we add water, and this is a solution before dilution. We add water, and this water should be 150 centimeters cubed, so that the total 150 plus 100 is 250. So that the total amount of water, or rather the total amount of solution is 250. So it will go up. So in the long run, the whole solution now is 250 centimeters cubed. When you do that, because this solution is 2m, when you add water, its concentration will go down. Its concentration will go down, it will shift from 2m, and the resultant solution will be now 0.8 m. And that is how we dilute solutions. And the most important thing to remember is M1 V1 is equal to M2 V2. Thank you for listening to me.